Okay, part B. Two students, Ellie and Sue, are trying to find the inductance of a coil using a 12 volt 50 Hz AC supply. Ellie connects a variable capacitor whose capacitance can be varied over the range of 100 to 300 microfarads in series with the coil. Ellie adjusts the variable capacitor until the voltages across it and the coil are exactly equal in magnitude. This happens, the value of the variable capacity when this happens is 219 microfarads. Ellie then uses the relation F equals 1 over 2 pi root L over C, which is our resonance for a LC circuit. That's when omega L equals 1 over omega C. She uses that relation to get a value of 46.3 millihenries for the inductance cell. Show how Ali carried out his calculation, or he uses that. Show that how Ali carried out his calculation and explain what he has assumed about the coil. Show the calculation and don't forget that last explanation bit. I think I've just said how to do it, so let's do that. I'll take all that off because you're going to have to write another explanation anyway, so I may as well remove it and write it again. So, variable capacitor, the inductor is what we want to find out. No resistor in that one, we've got a voltage over there and a voltage over there. Okay, so resonance, 1 over omega C equals omega L. So that gives you omega squared equals 1 over LC. Omega equals 1 over root LC, or indeed frequency is omega over 2 pi. 1 over 2 pi root L over C. Question I don't think asks you to come up with that. I think it just gives you that, but then how to use it. So resonance C equals 219 times 10 to the minus 6 farads. F equals 50 hertz, I think, in memory, 50 hertz. So we just need to rearrange that expression there for L. So we start F equals 1 over 2 pi root L over C, 2 pi F, bring that up there, bring the root C up as well, just to keep L on its own, equals 1 over root L. So I want to square and reciprocal, so if I square I've got 4 pi squared F squared C equals 1 over L. And now reciprocal that, L equals 1 over 4 pi squared F squared C. Put the numbers in, 1 over 4 pi squared, F is 50 hertz, square that. C was 219 times 10 to the minus 6 farads. And the answer is .0.463 henries. 0.0463 is, there's your milli, 46.3 millihenries. Okay, so that's worked out. Good to see that. So that's your first bit. Explain what is assumed about the coil. Well, we've assumed in getting that we have a resonance condition that's perfect. Well, it's a perfect inductor, essentially, is what's been assumed. Because here's our VL, VC. And if we have a little bit of resistance in there, we've got a VR term there. So if this coil were actually that, we'll sneak in a resistor there, and we're measuring the voltage over that plus that. What we're actually measuring then is that voltage there, the hypotenuse there, and the method has said that this equals the length of that, and of course if that equals that, this hypotenuse is not the same as this one here. So that formula is not quite going to apply in that case. So the assumption is a perfect inductor, which basically means R for the inductor equals 0. Of course, in reality, you don't really get perfect inductors. The coil's a wire. Wire has a resistance. I think that's the only assumption we need. I might think of something else later, but I think that's the key assumption there.